this practical, I'm going to be calculating the amount of dissolved oxygen in water sample. So here I have my water sample and my reaction vessel for doing the reaction in. I'll be using solutions of sodium thiosulfate, a solution of potassium iodide and sodium hydroxide, which I've made up here, a manganese sulfate solution, and sulfuric acid concentrated solution. I'll also be using starch as the indicator for this reaction. So to start the reaction, we need to rinse our reaction vessel with deionized water. Followed by rinsing with the water sample that we're going to analyze. We can now fill our reaction vessel and ensure it's filled right up to the top. Next, I need to add in the reagents to find out how much dissolved oxygen we have in the water sample. First of all, we add in the manganese sulfate solution, 1 milliliters. Followed by 1 milliliter of the sodium hydroxide potassium iodide solution. Ensure that the tip of the pipette is in the water solution so you're not getting any oxygen out of the air. You see a brown precipitate appearing. Next, we put a lid on the container. Divert the solution. And now carefully add concentrated sulfuric acid until the precipitate disappears. And divert and shake until the precipitate dissolves. And once the cloudiness disappears, we can now start the titration. First of all, we rinse the burette with deionized water. We let that run down through the burette, and then we rinse with the solution it's going to contain, sodium thiosulfate solution. Ensuring the tap is closed in the horizontal position, you can then fill the burette with the thiosulfate solution, filling above the 0 mark. Ensure you remove the funnel so there's no drops to drop into the solution. And then open the tap and bring the meniscus down until the bottom of the meniscus is in line with the graduation mark at eye level. The burette is now ready to use. It is in the vertical position and I have filled below the tap. Now we need to clean the pipette. So first of all, we rinse with deionized water. Insert the tip of the pipette into the pipette bulb. Press the button mark A to expel the air. Then draw the liquid up into the pipette by pressing the button marked S. Then let the liquid run out. Then blow the last remaining drop out of the pipette. And now we need to rinse it with the solution it's going to contain, our water sample. Now I'm going to rinse the pipette with the water sample. So again, draw the liquid up into the pipette, rinse the pipette, then discard that solution and blow out the last remaining drop. For this titration, we need 100 milliliters of sample. So I'm going to take 2 measurements of 50 milliliters into my conical flask. So draw the liquid into the pipette and fill the pipette up to the 50 ml graduation mark. If you accidentally go over the graduation mark, like so, you can release the liquid by pressing the button mark E until the bottom meniscus is in line with the graduation mark. I have now 50 ml in the pipette. I can let this run into my conical flask. So let the liquid run out of the pipette. Then when the liquid stops dropping, touch the pipette off the side of the conical flask, let the liquid run out, hold for a few seconds, and then you deliver 50 milliliters into the conical flask. I'll now do this a second time, so I'll have 100 mils in the conical flask and ready for the titration. Now that we have our 100 mils of our water sample and our burette is full of our sodium thiosulfate solution, I'm going to slowly add sodium thiosulfate solution until the solution turns a straw yellow colour, while constantly swirling. At this point, I will now add starch indicator to get any remaining free iodine will show up turning a bluish black colour. This is very near the end point of reaction, so slowly add thiosulfate until the solution turns colourless. The reaction is now complete, and I can now measure how much sodium thiosulfate I've used and then calculate the amount of dissolved oxygen in my water sample. With this sample in front of me, I've only half filled the bottle with the water that we're analysing. The remaining of the bottle has got air containing oxygen. You will see that this solution goes a lot darker due to more oxygen in the container. When I add in the sulfuric acid, this will dissolve the precipitate. And we can visually see a lot more free iodine, hence an awful lot more oxygen dissolved in the solution.